Welcome back, guys. It's Peter McMahon. I'm going to be giving you guys the second lesson in our calculus course right now for Math 31 AP, and we're going to be doing what we call the power rule. So the power rule is this guy over here. So we call this guy the power rule guy because this is x to the power of 4. So this is going to be what we're going to do, guys. I'm going to do this question the long way here, and then I'm going to teach you the kind of the shortcut way in a moment over here as well. So here's how we can get into this guy. All right, so Formula 1, we talked about this one in the previous lesson, guys. And for Formula 1, we have f prime of x equals the limit as x approaches a of f of x minus f at a all over x minus a. Okay, so in this case, it's going to equal the limit as x approaches a of f of x, which is x to the fourth, minus a to the fourth over x minus a. Now, strategy for these types, we want to be able to factor this guy. X to the fourth minus a to the fourth is x squared plus a squared over x squared minus a squared. Now, we're not quite done here because we can still factor x squared minus a squared. All right, so we have this guy fully factored, and we have an x minus a in the top and the bottom, and these guys are going to be able to cancel out, okay? So again, the whole premise behind formulas 1 is you want to be able to cancel out the x minus a in the bottom and then be able to substitute your value in. So I'm going to take this x and put it in for the a over here. So this equals x squared plus x squared times x plus x over here. So x squared plus x squared is 2x squared times x plus x is 2x, which gives us an answer of 4x cubed. Okay, so in other words, f prime of x equals 4x cubed, and this is the derivative of x to the fourth that we had there. Okay, now what I want you to notice over here is like the power rule is y equals x to the n. Okay, so like if we look at the previous example that we did, we had y equals x to the fourth, then y prime equals n times x to the n minus 1. So what would that be in this case? In this case, n equals 4. So that means then y prime, this is another way of writing the derivative, just a y prime, equals, well, the n value is 4, so 4x, and then n minus 1. 4 minus 1 is 3, okay? So what we saw in the last one is our answer was 4x cubed over here, okay? Now, guys, this is far from a proof of this one over here. Guys, there's a proof in your textbook, and in class, I'll kind of show you how this proof works as well, guys, but it's a bit lengthy right now, so I'm not going to worry about it in this video over here. The idea of the power rule is if you have x to some power over here, now this n here has to be some sort of real number. Okay, it doesn't have to be a natural number, guys, but it has to be some real number. And we're just following these rules over here. We just bring down the coefficient in front, and then the power goes to be 1 less. So in this case, we have y equals 4x to the 7th. So what's y prime going to be? Well, the 4 is still there. The rule for this is the 7 comes down, and then we go to 1 less like this. So 4 times 7x to the 6th. 4 times 7 is 28x to the 6th. There's our derivative for the first one. Okay. Now for the next one, I'm just going to write this over here. F of x equals the fourth root of x cubed. What I want to do is write this as an exponent. Okay, the fourth root of x cubed, guys, we can rewrite as f of x equals x to the 3/4, and now we're just going to follow our rule. F prime of x equals the 3/4 comes down in front, and the exponent goes 1 less. 3/4 minus 1 is negative 1/4 like this. Okay, so that means f prime of x equals 3/4 times the fourth root of x. So the negative brings it down to the bottom, and then 1/4 is going to be the same thing as the fourth root. Okay, so this would be our derivative for this guy over here. All right, 5 over x cubed. What's the derivative of this guy going to be? Well, I'm just going to rewrite this one like this. 5 over x cubed is the same thing as 5x to the negative 3, like this. That means g prime of x equals negative 15 x to the negative 4, like that. So the negative 3 comes down. 5 times negative 3 is negative 15, and I go 1 less than negative 3 is negative 4. And I can just write this as negative 15 over x to the 4th, like this, okay? So point, guys, over here is like that. This is getting much simpler than what we were doing before over here, okay? So it just, I mean, using Formula 1 and Formula 2 is a very long and cumbersome way, okay? And so the rest of this unit, we're going to teach you as new rules. The power rule is the first one, to be able to kind of go get faster and get better results for this guy over here, okay? H of x equals 7, okay? Now, I'm going to do this one the long way, but I'm going to look at this one graphically first. What's y equals 7 look like? Well, that's going to be a constant function or horizontal line like this. Now, hopefully, so the question is like, what's going to be the tangent? Well, a constant line has a slope of 0 all the time. So at any point, the slope of that line is always going to be 0. So the answer should be 0. Here's a way we can kind of get there, see it algebraically. You do not need to do this all the time, but just h of x equals 7 is same thing this time, 7 times x to the 0. So that means h prime of x would equal 0 times 7x to the negative 1, which is just going to equal 0. Because there's kind of a, so still using the power rule to be able to get this guy over here. But I think if you're going to see this, guys, this is a horizontal line. Okay, well, the slope of this guy is always going to be 0, like that, you know, because that's what a horizontal line is. Example number 3. Because guys, you can see quite a few of these questions in this unit. You'll see this one like in the product rule and the quotient rule and the chain rule, all these sections like that. You can see this type of question over here. Calculate the equation of the line tangent to the curve at the point negative 240. Okay, so 2 things we need, guys, to figure out the equation of a line. You need to have a point, and you need to have the slope. Okay, it's going to be the 2 pieces of information you need to be able to figure this out now. So the curve y equals 5x cubed, we're going to start by taking a derivative. Okay, y prime equals 15x squared. Okay, so that's what our derivative is going to be. Okay, now what we want to do is this derivative, again, what that gives you is a function that gives you slopes of tangent lines. Okay, so if I go y prime at negative 2, it's equal to 15 times negative 2 squared is 15 times 4, which is 60. Okay, that means that for this graph over here, y equals 5x cubed is going to be like a cubic function like this. And this is just definitely not scaled. Okay, but say negative 240 is this guy down here. This is saying that the tangent at this point has a slope of 60. Okay, so that's what this is saying over here. So now we have the point and the slope, and you do not need to write out this formula every time. But I'm going to write the equation of the line in point slope form. It becomes y plus 40. It's really y minus negative 40. Simplifies to y plus 40 equals m, which is 60, times x minus negative 2, which becomes x plus 2. And here is the answer for this guy over here. Okay, so y plus 40 equals 60 times x plus 2. Okay, determine the point on the curve y equals square root of x, where its tangent line is parallel to the line x plus 4y equals negative 9. Okay, so bit of review from Math 10. So you guys, parallel lines have equal slopes. Okay, so here's what we're saying. We have a curve y equals root x. Okay, I'm just going to take a look at this one over here. This is 4y equals negative x plus 9. That means y equals negative 1/4 x plus 9 over 4. Guys, I made a small mistake over here. I'm going to change this question here. So please make that, sorry guys, I'm going to change this to a negative x plus 4y. Sorry guys, this is my fault over here. And that would mean this is positive and this is positive over here. There we go, okay? So what this is trying to get over here is like plus 9 over 4 is like 2.25. Our line's going to look something like this guy over here. Okay, so here's our line over here. Now, if you look at the curve over here, I'm going to do my best to kind of estimate here. If I kind of draw this point over here, my tangent line would look like this. Okay, now again, this is a very kind of rough sketch over here, but hopefully you can see that this line is parallel to this line over here. Okay, so this is kind of how we can kind of visually see how this guy works over here. Let's see how we do this one algebraically. Again, how do we deal with slopes? Well, slopes can be found using derivatives. So if I have y equals root x, the same thing as x to the 1/2, that means y prime equals 1 over 2 x to the negative 1/2, which is 1 over 2 root x, like this. Okay. Again, what's this give us? This gives us slopes of tangent lines. All right. Okay. So now what we did over here is, like, again, after we fix this problem over here, y equals positive 1/4 x plus 9 over 4. That means the slope of this line is m equals 1/4. Okay, so what we're going to do here is I'm going to put an m equals 1/4 here. And now we're going to solve this guy for x. Okay, so solve this guy for x. I'm going to multiply both sides times 2 root x, multiply both sides times 4. That means 2 root x equals 4. That means root x equals 2. Square both sides. That means x equals 4. Okay, so what it's telling us so far is that this point over here that we've identified has an x coordinate of 4. Now we just need to come back and figure out what the y coordinate is. That means y equals 2. Therefore, the point is 4, 2. This point over here must be 4, 2 for that one to work. All right, guys, I hope that makes sense in how we did this example over here. Let's move on to the next one. Okay, definitely this is going to be the harder question on this section over here. So determine the equations where the lines tangent to the curve also pass to the point 3, 11. Okay, so we have the curve y equals 4 minus x squared, and then we have this curve passing through the point 3, 11. So first of all, guys, hope you recognize the point 3, 11 is not on our parabola over here. What it's saying is that some point on the parabola, okay, well, the tangent would pass through this point over here. I'm going to do my best to eyeball this guy over here. If I draw a tangent like this, you see how this line is tangent to the curve at this point, and then it's passing through the point 3, 11. I'm going to do the same thing like this. It's not a great line, okay? But hopefully, guys, the line's going to be tangent about here, also passing through this one over here, okay? So, tricky question on how we do this, okay? Now, here's the approach we're going to take. I'm going to call this point over here x, 4 minus x squared. Okay, so again, we don't know what this x value is, but I mean, whatever the y value is going to be 4 minus x squared based off this guy over here. Okay, now what I'm going to want to do is I want to figure out the slope of this tangent line in 2 different ways. Now, the slope of the tangent line doing 1, if I have y equals 4 minus x squared, that means y prime. Derivative of 4 is 0. Derivative of negative x squared is negative 2x. This is the slope of the tangent line over here. So we'll call this guy over here equation number 1. Now, equation number 2, I can just use like a rise over run calculation between this point and this point over here. Okay. that would be m equals 11 minus 4 minus x squared over 3 minus x, like this. Clean this up a bit. 11 minus 4 is 7 plus x squared over 3 minus x, like this. Okay, so here's going to be my second way of writing my slope calculation here. Okay, now the idea is that the slope of this line using my slope calculation or my derivative should be the same thing. Right? So these are just two ways of writing the slope of the tangent line at this value of x over here. So in other words, what I'm going to say is that this value of the slope is going to equal this value of the slope over here. Negative 2x equals 7 plus x squared over 3 minus x. Okay, so so how's this going to work next? We're going to figure out the equation. So now we're going to solve this guy for x. Okay, so I'm going to multiply both sides of the equation times 3 minus x times 3 minus x and multiply this through. That means we're going to negative 6x plus, sorry guys. So negative 6x plus 2x squared equals 7 plus x squared, like this. Okay. Now let's bring 7 plus x squared, bring it over to the other side over here. 2x squared minus x squared is x squared minus 6x minus 7 equals 0. So this is a quadratic equation now. Factors very nicely for us to x minus 7 times x plus 1 equals 0. So therefore x equals 7 or x equals negative 1. Okay. So what this is getting at over here, looks like this point was actually a pretty good guess over here. That means that this value over here is negative 1. That means this x coordinate over here is 7. Okay. So next thing we need to do, we need to figure out what are the y coordinates corresponding to these points over here. Okay. So I'm going to say, well, f at negative 1 is 4 minus negative 1 squared is 4 minus 1, which is 3. Negative 1 comma 3 over here. F of 7 is 4 minus 7 squared. Okay, 4 minus 49, which is going to be negative 45. Okay, so our point is 7, negative 45. So definitely would have been off the screen over here. So this point is actually going to be further lower down over here. And this guy's negative 1 comma 3. Okay, now, you guys, I'm just going to take one quick little pause here. Sorry, I need another page. So here's our diagram again. We saw earlier on that our derivative was y prime equals negative 2x. Okay, so therefore, this is like line number 1. My m is going to equal negative 2 times negative 1, which equals 2, right? So it's negative 1. My slope, my derivative was negative 2x for this function, so it means that this guy's going to be 2. So that we know m equals 2. It passes through 3 comma 11. So it's going to be y minus 11 equals 2x minus 3. There's equation number 1. Okay. Now for this one, I'm going to call this one y equals 2. Well, the derivative is still y prime equals negative 2x. So for m equals negative 2 times 14, that means m equals negative 28 for this line here. So we have y minus negative 45 is y plus 45 equals negative 28. x minus 3. This is going to be the second equation over here. Okay. So guys, this is definitely kind of a quick lesson. Intro to the power rule. Showed you some of the easier ones, some of the hard ones as well, guys. Again, guys, just want to reemphasize, I did not prove this for you. I just kind of showed you how it works over here, guys. The proof is in the textbook, and I'll be happy to show it to you guys in class how this one works as well, guys. Hopefully that Mr. Penkoff or Mrs. Chaudhry showed you how this one worked earlier on in January. Okay, but this is kind of how this guy works over here. All right, guys, I'll see you in the next video, which is called the product rule.